How are everyone doing today?
I'm good. How are you?
I'm doing fine, thank you. Thank you for asking.
All right.
I have only 11. Oh man. Okay. So today we'll do Trig. Did you guys start Trig in your class yet?
No, we haven't.
Oh, wow. That means I'm ahead of your schedule. Okay, no problem. So trigonometry is very much fun if you understand, and it sucks if you don't understand, just like other math. But like compared to calculus or other topics in pre-calculus, trigonometry is much more fun actually. Except for one topic, graphing. Graphing trig function is not that bad, but I find it annoying, and many students also told me that this is the hardest topic for them. So welcome to the trigonometric world. You'll hear me cough a lot because I'm not feeling well, so my throat is burning and everything. So, in trigonometry, there are very few important concepts. One of them is unit circle. It's called unit circle because in this circle, every radius is 1 unit. Thus, it's unit circle. So, in the unit circle, we can have both measurements. So in trigonometry, you have two types of measurement. One is in degree measurement and one is in radian measurement. So in the unit circle, we can put both of them together, and based on what you are trying to find, you can find any angles from these angles from the unit circle. Now, first thing I'm going to show you is how to convert all these degrees into radians. So if you observe, we have this is either 0 degree or 360 degree. And it's 0 degree if you just stay there at 0 degree. It's 360 degree if you get one full circle. If you round around, if you need circle once, you get 360 degree, which is same as 2 pi radians. Now, from 0 degree to, if you move a little bit up, like here, this angle is 30 degree. Now we are going to find how do you write 30 degree as a radian. In order to do that, you need to remember that conversion factor. Abdul, are you talking to me? No? Okay, so conversion. We say 180 degree is pi radians. Okay, so anytime you see 180 degree, like for example here, from here to here we have 180 degree, which is same as pi radians. Now, based on that, we can convert radians to degree, degree to radian. For example, we want to convert 30 degree into radians. So what you're going to do is, since we don't want the degree anymore, so we put 180 degree on the bottom and pi radians on the top. So the degree and degree cancel out. We left to it a quantity in radians. Now 0, 0 cancel out. 3 goes to 18 6 times. What does that mean? It means we have our answer pi over 6. So this 30 degree is same as pi over 6 radians. So some people like to use radians to represent their angle. Some people like to use degree to represent their angle. I personally like degree because I can see the location of degree, but the location of radians, I don't see it unless I convert them into degree. So I'm a degree fan, but most trigonometry people, they're actually radians fan. So that's how we convert degree to radians. And we can also go other way around, radians to degree. Let's say you know that you have, let's say, 7 pi over 11 radians. Now you have no idea where is this 7 pi over 11 in the unit circle. Well, no problem, because we can convert this into degree. So now we don't want the radians, so we put pi radians on the bottom and 180 degree on the top. So you see this pi radian and pi radian, they cancel out. And if you multiply 180 times 7, so we have 180 degree times 7, and you divide by 11. If you use a calculator, actually 7 not going to give us anything. No, wait, 7 pi over 11, 7 pi over 11. Let's see what degree is it. So we have 7 times 180 divided by 11. It's the perfect number, 114.5. So this is 114.5 degree. So it's somewhere 114, somewhere here. Okay. Any question about the conversion, how to convert radians to degree or degrees to radian? Any questions so far from anyone? Are you guys okay with this? Do you want me to show any more conversion, or I can go to the next concept? Any comments? No?
Can you show me one more?
One more? Okay. So which way you want to go? Degree to radians or radians to degree?
Degree to radians.
Degree to radians, okay. So let's say they are saying that write 225 degree in radians. So 225 degrees here. So 225 degree. Since we want to convert degree to radian, that means you don't want the degree. So whatever you don't want, that always should be on the bottom. Since we don't want the degree, so 180 degrees should be on the bottom, so you can cancel our degrees. And 180 degree is pi radians. Yeah, always 180 degrees pi radians. So use that conversion factor. And then you simplify. So when you simplify, both of these are divisible by 25. First, let's do it by 5. Or maybe 225 is fine. So let's see. 225 divided by 25 is 9. And 180 divided by 25. Really? I cannot divide? Oh, man. Okay, never mind. We cannot reduce by 25. So let's say 5. 225 divided by 5 is 45. So we have 45 here. And 5 goes to 18, 5, 56, right? Let me just make sure. 180 divided by 5, 36. Now both of these are divisible by 9. So 9 goes to 36, 4, 9 goes to 36, 5. So this is same as 5 pi over 4. And you cannot reduce this anymore. So once you multiply by the conversion factor, you reduce, and the smallest number, when you cannot reduce anymore, that is your answer. So 225 is same as 5 pi over 4. Okay. Let's do one more the other way around. Let's say this time they give you radian. Let me pick 11 pi over 6. 11 pi over 6. It's 11 pi pi. Now 11 pi over 6, in order to convert this into radians, because we have no idea where this is located in the unit circle. So this time we don't want the pi. That means we want the pi on the denominator so we can cancel them. So if pi goes on the denominator, 180 has to go on the numerator. So 6 goes to 180 30 times, and 3 times 11 is 330. So 11 pi over 6 is 330 degree. 330 degree is here. So this is 11 pi over 6. So Abdul is asking, what's the point of the unit circle? The point of the unit circle is that you would like to know what is the trig angle for any, what is the value for any trig angle. For example, what is sine 30 degree? How much is this? How much is cosine 30 degree? How much is tangent 30 degree? So you can find the value for any angle using the unit circle. Well, unit circle is not the only thing you can use to find an angle, but people say this is one of the most useful tool to have in order to find your angle for the value for any angle. For example, if you'd like to know what is sine 225 degree. So to find 225 degree, you can go to the unit circle and you can find them. Now the question is, how do you know how much is cosine and how much is sine? So in order to find that, we need to use a new trick. So first thing we learn how to convert degrees to radians and radians to degrees. That means you can fill out all these boxes. So 90 degree is half pi because pi is 180 degree. So 90 is half of that, so it's half pi. And then see all these things, they represent something. What do they represent? The first thing is the x value. The second thing is the y value. Now, you may wonder, well, how do you find this x and y? Or why do you have to work with this x and y? Well, we have to work with this x and y because these x and y, they are actually not the variable. They are trig function. X represent cosine function, and y represents sine function. Okay, so whatever we have in that position for x value, that is the value for the cosine angle, cosine for that angle. For example, we have 45 degree right here. Now, whatever we have in the x position, that is cosine 45. Whatever we have in this y position, that is sine 45. So we definitely would like to know what is sine 45, what is cosine 45, what is tangent 45, those. So in the unit circle, the tangent is not directly given, only the x and y given. But we do know there are identities that our tangent is sine over cosine. That means if you divide your y term by your x term, you can get your tangent easily. So unit circle only has sine and cosine, which is x and y. And based on the sine and cosine, you can figure out any trig angle, any value for any trig angle. So now how do we find all these x values and y values? Well, let me show you a fun trick. This looks messy. Let me erase everything so that it looks nicer. Now the trick, I actually didn't know that when I first learned the trick, but when I learned it later, many years later, I was like, oh man, this is so cool. I didn't have to memorize anything. I could simply use my hand to figure this out, the value for any x and y. So what is the trick? You can assume your angles as 5 fingers on your hand. So if you have 8 fingers like this. We have 5 fingers, and each finger represents every angle in the unit circle. So this is 0 degree, this is 30 degree, next we have 45, and then we have 60, and then the straight line is the 90 degree. So we have 5 angles in the first quadrant, if you observe. We have 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. One cool thing about the unit circle is that if you only know your first quadrant here, the value of your first quadrant, that means you know everything else for every other quadrant. That's the cool thing about unit circle, because every number you have in the first quadrant, they actually repeat. So let me show you how they repeat. So whatever you have for the 30 degree here, why do I have this? So whatever you have for the 30 degree, I wanted to make it nicer. So whatever we have for 30 degree, if you go straight on the road, this 30 degrees corresponds to the angle 210 degree. So whatever x and y you have here, whatever x and y you have here, the exact same x and y value we have there, just the signs are different. For example, in the first quadrant, every x and y value we have, they all are positive. But in the second quadrant, our x is negative and y is positive. Our third quadrant, our x is negative, so is the y. In the fourth, x is positive, but the y is negative. Why do we care? Well, we care because whatever we have for the 30 degree, we are going to have the exact same thing here, but this time they will have negative sign in front because they are in the third quadrant where both x and y is negative. Similarly, let's say a 60 degree. Whatever you have for 60 degree, you have the exact same thing for 240 degree because they go on a straight line. So in here, we have positive x, positive y. Here, you're going to have negative x, negative y. The same numbers, that's a different sign. Now, this is how quadrant 1 and quadrant 3 connected. Now, look how quadrant 1 and quadrant 3 is connected. So 2. So whatever angle you have here, you have the exact same angle here. So how much you have here? You have exactly same angle here. Also, you have exactly same angle here. And exactly same angle here. So this 30 degree is 30 degree on the first quadrant. It's the same 30 degree here on the second quadrant, same 30 degree here on the third quadrant, and same 30 degree here on the fourth quadrant. So if you know your 30 degree for first quadrant, that means you know your 30 degree for 150 degree, 210 degree, and 330 degree. Cool, right? You just have to know one quadrant and you know the rest of the quadrants. Similarly, let's say you're working with 60 degree. So whatever we have for 60 degree here, you have the exact same 60 degree here. So this is 60 degree from here to here. From here to here is also the 60 degree. That means here, this is also 60 degree from here to here. And from here to here is also 60 degree. So if you know one x and y for 60 degree, you know how much is for the second quadrant, how much that is for the third quadrant, and how much that is for the fourth quadrant. So this and this second and fourth quadrant, they have straight connection. First and third quadrant, they have straight connection. That's why people love unit circle, because it's cool. Personally, I don't use unit circle because I don't memorize them. I only memorize the first one, and then I use go pi unit to get the other one. So if you know here, you add pi unit and you get this one. But anyway, so let me show you how to find all the first quadrants. So the trick is, let me take blue. For every x and y, so we have x value and y value. For every x and y, first you divide them by 2, okay? And then you do square root. Now, x value, to find what goes in the numerator under the radical, you look at how many numbers you have on the left of your finger, that finger. And for y value, you count how many numbers you have on the right of your, so left fingers, and here we have right fingers. So from 0, from this angle, you have 1, 2, 3, 4 fingers on the left. So 4 goes here. And we don't have any finger here, so 0 goes there. And then you simplify. Square root of 4 is 2, 2 divided by 2 is 1, and 0 divided by anything is 0. That means at the origin, at 0 degree, we have cosine 0 degree is 1, sine 0 degree is 0. And we know tangent is sine over cosine, so it's 0 over 1, which is 0. Okay? Clear? Any questions so far? So here you see, we have the x value 1, y value 0. You didn't have to memorize that because we can find that easily using our fingers. Now let's see you working with 45 degree or 60 degree. Let's say 60 degree because I already have marked for my 60 degree. So for 60 degree, this is the finger I have. So our x has only one finger on the left, so square root of 1 over 2. And for y, we take how many we have on the right. So we have 1, 2, 3 on the right, so it's square root of 3 over 2. Now if you simplify this, it becomes 1/2 and square root of 3 over 2. What does that mean? It means sine 60 degree is square root of 3 over 2. Cosine 60 degree is 1/2. That's going to give us a tangent. Tangent 60 degree is root 3 over 2 divided by 1/2. That gives us root 3 over 2 times 2 over 1, which is root 3. So where do you put them? Here we found that our sine x value is 1/2 and y value is root 3 over 2. One half and root 3 over 2. But in this quadrant, our x is negative, so you're going to have a negative 1/2 and positive root 3 over 2. On the third quadrant, they both are negative, so let me clear this a bit. So here our x value is negative 1/2 and y value is negative root 3 over 2. And on the fourth quadrant, which is here, our x value is positive, so 1/2, y value is negative, so negative. So you found only, but you actually found 4 of them indirectly. And you can use your finger to fill out the first quadrant and just draw your line backward to get the other ones. So the thing you have to memorize or remember is this. Actually not this, the entire thing. Let me highlight this. That x is the left finger, how many you have, and y is how many you have on the right fingers, the right side. And then the denominators are always 2, and numerators are square root of how many you have, how many fingers you have. Any questions so far? Any comments, concern, complaint, anything? So many people use many different methods to remember the unit circle, but for me, I found this is one of the easier way of remembering the unit circle. And if you can't even remember the unit circle, you're completely fine. Like I don't remember the unit circle, but see, I lived my life very well without the unit circle. Now so your job is to fill out every other information here. Fill out all the boxes and fill out all the X and Y values. And can you see it as well? No, we can't. So to find this, you can go to recitation worksheet, and then this is the seventh one, week 7 unit circle. So if you click on it, you'll see this worksheet. You can fill out using your tablet or anything, or you can print them out and then write on it. And then to upload, you go to the next option and you see unit 7 uploads. You actually have to do it by Friday, Friday before midnight. You click on start, upload your first question, upload your file, and then submit. I noticed many of you didn't do any of the worksheet. So, oh, sorry, my bad. If you haven't done anything yet, I'll give you one more chance, okay? Only one chance. By next week, make sure you complete all of them from 1 to 7, all of them, and bring them in class. So this is a one-time chance, okay?
Professor?
I'm not going to give this chance again. If you haven't done anything yet, make sure you complete everything. Go ahead,
Professor?
Zulekha, right?
Yes.
Yes.
I did a few of them online and I gave you some two maybe on the paper. Is that okay, right?
Yes.
If I give you paper, so I don't need to submit online, right?
So if people don't know how to upload, right. So I don't know why they did not submit online, many people. So if you think you don't know how to submit online, I'm giving you a chance, one-time chance to everyone. Make sure you bring all of the papers on next Tuesday. Sorry, not Tuesday, next Wednesday. Okay, in person. But then you should learn how to upload anything online, because many times, like during pandemic, we had to do everything online. So you should know how to upload them. But if you did not, I gave you 6 weeks. Actually 7 weeks. Today is the 7th week. I gave you 7 week chance to learn it, and then I cannot give you any more time. So all the recitation from 1 to 7, if you have no idea how to upload them, make sure you learn them. But I'm giving you the chance to submit so that you don't lose any points. These recitations are 10% of your grade. It's a lot. If you don't complete them, you're losing 10%. Means there is no way you're going to get A or A minus in this class. No way. It doesn't matter how much you have 100% in your homework or quizzes or in your exam. That if you lose 10% means you're losing. You have only 89% to 90% to play around with. So you cannot get any E or A minus in this class. Okay, so this table here, they're just telling you give the sign for each trig function. So like I said, y is the sine, sorry, sine is the y value, cosine is the x value. So how or what sign we have for y in each one? Well, give me a second. So they're saying for each trig function, what sign you have in each quadrant. So y is positive here, and y is positive here, and y is a negative here. On the other hand, x are positive on first and fourth, and it's negative on second and third. So that's all you have to do. You don't have to do any math or anything. Just write what sign we have for each trig function on every quadrant. So you may wonder, well, sine and cosine you can see easily because they're x and y, but how do we do the other ones? Well, we can do the other ones because we know tangent is y over x. It's a sine over cosine. So it's y over x. Now, cosecant is 1 over sine. That means whatever sine has, it has the exact same format. Secant is 1 over cosine. It means 1 over x. Basically, it's x. So this is basically y and this is basically x. Cotangent is 1 over tangent, which is x over y. So they are reverse of one another. But they have the same format. Tangent and cotangent, they have the same format. Sine and cosecant, they have the same format. And cosine and secant, they have the same format. Okay, so if you know sine, cosine, tangent, just copy the exact same thing for the other three and you'll be fine. Any question? And also there is one expression people use to remember the signs. This expression is, never mind. Actually, let me tell you. This expression is like this. All students take calculus. What does that mean? It means every trig function is positive on the first quadrant. Student means you're just looking at the first one as sign. So sine is positive here, and the inverse of sine, which is cosecant, is positive here. All the other four are negative here. Take means you're looking at the t, which is tangent. So tangent is positive here, and whatever we have with the tangent, like cotangent, that is also positive here. So only tangent and cotangent is positive in the third quadrant. Everything else are negative. Calculus means you're looking for cosine. Cosine and the inverse of cosine is secant. So only cosine and secant are positive here. Everything else are negative. So all student take calculus tells us the sign, not the letter sign, the mathematical operation sign for every trig function. But again, why do you care? Because based on where your angle is, we have different signs for our value for the trig function. Any question? So these are alternative of the unit circle. If you know unit circle, you have everything you need to know for trig. But let's say you're not a unit circle fan like me. You don't like the unit circle. Then this is the trick to remember your signs for every quadrant, for every trig function in every quadrant. And this is also another trick to remember your angles without using trig function, so without using unit circle. So the second trick is complete this table. So 0 degree, this is 30 degree, this is 45 degree, this is 60 degree, and this is 90 degree. So this table is useful for these 5 angles, just like the first quadrant of the unit circle. Now, whatever trick we used on the unit circle, you can use the same trick here. First, we fill out the table for sine. Now what you do is you do square root something 2. So square root, oh my bad. Square root and then 2, square root of blank and 2, square root of blank and 2, square root of blank 2, square root of blank 2. And then you don't have to count how many fingers you have. You can simply write 0, 1, 2, 3, 4. And then just simplify. So when you simplify, 0 divided by anything is 0. So we have 0 here. This becomes 1/2. Square root of 2 over 2, we have nothing to simplify. Square root of 3 over 2, we have nothing to simplify. And this becomes 2 over 2, which is 1. That means without using the unit circle, you know what is sine, let's say 60 degree. Sine 60 degree is root 3 over 2. You also know what is sine 90 degree. Sine 90 degree is 1. You also know what is sine 45 degree. Sine 45 degree is root 2 over 2. Now the cool thing is this, once you know your sine, you don't have to know everything else. That sine will tell you to complete the table for the rest of the trig function. How? For cosine, all you have to do is write the numbers you have for sine in reverse direction. For example, sine have 0, 1/2, but you're going to write from left to right. Instead of writing from left to right, you're going to write from right to left. 0, 1/2, root 2 over 2, root 3 over 2, and then the last one is 1. So whatever you have sine going from left to right, for cosine, you're going to write them from right to left. They're the same numbers, just in reverse direction. Go ahead.
I have a question.
Go ahead.
In the sign category, the last thing like by 2, so like there's like -2 divided by 2, right? It remain like -1, right?
Which one you're talking about?
The first column, the last one, the square root of 4 by 2.
So square root of 4 over 2, square root of 4 is 2 divided by 2. So square root of 4 is 2. The 2 divided by 2 is 1.
Oh, yeah. Oh.
It's not minus, sorry. It's equal sign. My
okay.
bad.
Okay, sorry about that.
It's okay, my bad. I didn't have enough space, so I wrote it a little smaller. The sign tells us cosine, and now we know tangent is sine over cosine. So all we have to do is divide the first column by the second column. 0 divided by 1. Let me change the color. 0 divided by 1 is 0. 1/2 divided by 3/2 is root 3. Root 2 over 2 divided by root 2 over 2 are the exact same thing, so it turns into 1. Sorry, let me check my work. We have 1/2, we are dividing by root 3 over 2. So it's 1 over root 3, not only root 3. And we have root 3 over 2 divided by 1/2. So 2 cancel out. This is root 3. For the last one, we have 1 over 0, but we don't know how to divide by 0. So the last one become undefined. It doesn't exist. Do you see what I did? I took the first column, we divided by the second column. So 0 divided by 1 gives us 0. 1/2 divided by 3/2, square root of 3/2 gives us 1/3, 1 over root 3. Root 2 over 2 divided by root 2 over 2 is 1. And then the last one is 1 over 0. We cannot divide by 0, so it's undefined. That means if they ask you what is tangent 90 degree, the answer is it doesn't exist. Any question? Comments? Anything? So I gave you the first 3 rows. For the next 3, all you have to do is flip the first 3 and it becomes the last 3. For example, if you flip if you flip 1/2, it becomes 2. Let's take a different color. So if you flip 1/2, it becomes 2/1, which is 2. If you flip √3/2, it becomes 2/√3. And here we have 1/0, right? So this is 1/1. So if you flip, it still becomes 1. √2/2 becomes 2/2. And then we have 0/1. It becomes 1/0. But we have no idea what is 1/0. So this becomes undefined. So you flip sine to get the cosine. So to get the cosecant, you flip cosine to get the secant, and you flip tangent to get the cotangent. That's it. And if you have this table in front of you, when you do any trigonometric operation, you don't have to memorize anything. And you have to also memorize this table because you can derive this table. So either you can use unit circle or this table. And unit circle is the most helpful because it has every angle. And this table has only first quadrant. That's it. So if you want to find other angles, you just have to go back to the unit circle to see, you add the pi units, and then you get the result for the other angles they're asking for. Any questions so far from anyone? So first, the best one is the unit circle. If you don't like unit circle, then we have this table. And if you don't like this table, then we have one more trick, which is 2 special triangles. But there is a downside of these triangles. These triangles work only for 3 angles. It's useful only for 3 angles. Only for 3 angles. Does it? What are these 3 angles? 30 degree, 45 degree, and 60 degree. That's it. You cannot use these triangles for any other angles besides these 3. So this is the downside of these special triangles. But still they're helpful because we actually use these a lot, these 3. So to remember this, first you draw your special triangles. One side is 45, the other side is 45, and this is 90 degree. You also draw your 30 degree, 60 degree, 90 degree triangles. And then you decide your length. Not actually decide, you assign a number to each side of the length. So since we have 45 degree twice here, so that means whatever you have for this side, the opposite of this 90 degree, 45 degree, you're going to have the exact same thing for this side. So these two sides are same for 45 degree because we have 245 degree. So their lengths, the lengths of the opposite angle should be same. So how I remember is that since 45 degree is smallest here, then we take 1, the smallest positive whole number, and we assign that to both sides. And then if you add 45 and 45, you get 90. Same thing if you add 1 and 1, you get 2. but we cannot leave these two because it's a right triangle. So we have to trap this through inside the square root. Because this 90 degree is trapped between these two 45. So we have to trap its sum inside the square root. Similarly, for the other angle, the smallest one is 30 degree. So I'll assign the smallest number for the opposite side of the smallest angle, which is 1. And now between 60 and 90, 90 is the largest. So we are going to assign the next whole number for the largest angle. So smallest side gets the smallest number, largest side gets the next number. And if you observe, if 60 is trapped between this 30 and 90 degree. So it's in the middle. So in order to find the opposite of 60 degree, which is here, you add these two. So 2 plus 1 is 3. And then you trap it inside the square. And now you may wonder, well, why do you care about these angles? What they tell us? Well, they tell us what would be any trig function. For example, what is sine 60 degree? Now, in order to use the triangle, you actually have to remember your identities. Sine is opposite. Sine is opposite of our hypotenuse. So this 60 degree has opposite angle, opposite side is root 3. And this triangle has hypotenuse 2. That means sine 60 degree is root 3 over 2. Let's say I have to find tangent 45 degree. Now, you need to know what is tangent. Tangent is opposite over adjacent. Did you guys learn about these identities? What is tangent? What is sine? What is cosine? Did you learn about this in your class? Not yet. If you haven't, that means you're going to learn it. But if you already did, that means this looks familiar to you. So in terms of triangle, tangent is opposite side over adjacent side. So let's say you're looking at this 45 degree. This 45 degree has opposite side here, which is 1. And this has adjacent side here, which is also 1. 1 over 1 is 1. That means tangent 45 degree is 1. So you can use sine, cosine, tangent, cosecant, secant, cotangent, any angle, so any trig function for these 3 angles. To find their values, you can use these 2 triangles. So we'll learn 3 tricks today. One is the unit circle, one is the table, and now is the triangles. Any question about any of these? Was anything unclear, confusing? Nothing? So I actually showed you, or actually did almost everything for you. You had to do the last 2 row of the table, and you have to complete this sign chart for each trig function, and then you have to complete the entire unit circle. Any question before we leave? Any comments? Anything? Nothing? Okay, then see you all next Wednesday. And remember, I'm giving you the chance to get your points back, whatever you lost so far. So if you haven't done anything, or if you couldn't upload anything on Lumen, make sure you bring everything in person in the next class. Okay? So
Thank you.
have a good day, everyone. And
Thank you.
no problem. Bye, Daniela. Bye, everyone.